All right, now in this section 4-8, the topic here is solving logarithmic equations. So last time we solved exponential equations. Now we're going to move to solving logarithmic equations. And so the first part of the notes is really the same as the last section. Okay, so they're giving you keys and clues and things on how to solve these types of equations. And so again, same basic strategies. You've got the one-to-one properties and you've got the inverse properties. And so those will help you to solve these equations. Once again, you've got the same strategies here. So rewrite the original equation in a form that allows use one-to-one functions. Last time in the exponentials we tried to match the base. And so with this one, what we're going to find is, rewrite an exponential in logarithmic form and apply the inverse. Okay, but on this one, we're going to really use strategy number 3 more. Write a logarithmic equation in exponential form, and then apply the inverse property. So once we write the logarithmic equation in exponential form, we'll have it in a form that's easier and more easier for us to see how to solve it. Because remember, once we take the logarithmic function and turn it into exponential form, remember we just did a section on solving exponential equations, right? So that's kind of the strategies we're going to use. Let's look at a few examples. So let's say I wanted to solve this equation right here. All right, so log base 4 of x minus log base 4 of 8 equals to 0. Well, I can move this term over to the other side, right, and make it plus. And now look, log base 4 of x equals log base 4 of 8. Well, remember, when the bases here are the same, then that means that these also should be equal, right? So that means x equals to 8, one-to-one property, right? So going back here, right here, looking at this property, log base a of x equals log base a of y, if and only if x equals y. So remember, if the bases match, then this part also has to be equal. Okay. The next one, let's see. We got natural log of x minus natural log of 3 equals 0. Once again, move it over to the other side, change it to plus. Natural log of x equals natural log of 3. So the bases are the same. The basis is e. So again, this part has to be equal. So x equals 3, and we're done. Let me see here. Natural log of x equals to negative 3. Okay. So really, the strategy here is they're asking you to take this thing and raise it to the power of e, but really, and then go from here to try to say, hey, the bases match, right? They're trying to get you to match the bases, and then say, okay, if the bases match, then the exponents are equal, right? Okay, but really, the quickest way to do it is to take this and rearrange it. So rewrite the logarithmic equation in exponential form. So remember, your basis is e, right? Raised up to this power, okay, and it equals to x. So remember, natural log the base is e, raised up to the negative 3rd power equals to x. So x equals e to the negative 3. And then we can just figure out what that is. You may have choices where it has e in the answer. You may have choices where it takes it to a decimal. Either one will work out just fine. All right. So what about this one? Okay, so once again, if it's in log form like this, and you can't get the bases to match real simply, then just rewrite it. My base is 10 raised to the negative 1 power equals to x. So x is equal to 10 to the negative 1 power, or 1/10. This one, once again, rewrite it in exponential form. Okay, my base is 3 raised to the 4th power equals to x. All right, so 3 to the 4th power is 81. All right, so that's going to be our main strategy, either trying to make the bases match, right, and then these parts will be equal, or just rearrange it and put it in exponential form, and we can solve it that way. All right, look at some examples here now. So the first one we're looking at is the natural log of 4x equals to 2.1. All right, so at this point, the first thing that I want to do is I want to rearrange this thing, right? So this 4x, I'm just writing that first because I like my x to be on the left-hand side, is equal to the base, which is e, raised to this power, which is 2.1. All right? And so, again, I just rearranged it. This equals to the base e raised to this power. I'm just rewriting it from natural log to exponential form. All right? So from here now I can just divide it by 4 and we will come up with the right answer. And I can let my calculator finish it for me. Again, Desmos is a good tool to have on our phones. So really what I want to do is I want to find out what E raised up to the 2.1 power divided by 4 equals. And it's 2.04. So there's your answer. Right. Now if you wanted to check these, just like in the last section, you can get what you've got for x and plug it in. So let's try that. So I'm going to go for natural log, just to check this one. Natural log of 4 times 2.04. And we see we get 2.0999, which is, if I had extended it all the way out to the real decimal that we had gotten, then you would see that that's the correct answer. All right, so if you're ever not sure if you've gotten the correct answer, just plug it in, double check it, and see if you get it equal. All right, so next one. So what do you notice about this? Okay, we should be able to notice very quickly that the bases are the same, right? Which means this part is the same. So now this just simply becomes 3x plus 2 equals to 6 minus x. I want all my x's on one side, the regular numbers on the other side, so I'll go 3x plus x equals to 6 minus 2. Anything that goes across will change signs, right? So now we've got 4x equals to 4. And I can divide by 4, my x is equal to 1. If you wanted to double check that, you would see that you are correct. Okay? All right, what do we got next? So here on this one, first thing I want to do is to try to simplify that log term by just dividing both sides by 7. And so I'll have log base 4 of 0.6x equals to, let's just leave it as 12 over 7. Okay, so now I'm ready to rearrange it and put it in exponential form, right? And so I know that this number 0.6x is going to be equal to my base. What's my base? All right, so my base is 4. And we're going to raise that to what power? To the 12 over 7 power. So we have it raised up to a fractional power. Now I'm ready to divide it by 0.6, 0.6. I'm left with x equals, and I have a calculator that can get this value for me. So let's see what it is. All right, so I need a fraction, and it's going to be 4 raised up to the, underneath parentheses here, 12 over 7 power. All right, and then on the bottom of the fraction, divided by 0.6, and we have our answer, 17.95. All right, so there we go. Good shape of that. And so that brings us to the next problem, which is the natural log of the square root of x plus 2 equals to 1. And by the way, before we proceed, okay, one thing that I forgot to mention on these, all right, one thing that you want to make sure you do with all of your solutions is make sure that you're not getting something that's not going to be an answer, like an extraneous solution is a possibility on these. And remember, basically the extraneous solution that you want to check for is when you plug in, does it make you take the log of a negative number? Because remember when we first started talking about log, we said that number has to be positive, right? Or it can't be negative, right? So if I plug this in, would that make me take the log of a negative number? No, 2.4 times 4 is like 8 something, so we're good. What about here? If I plug in a 1, that's 3 plus 2 is 5, taking the log base 5 of 5. What about if I plug in a 1 here? Nope, that will still make 5, so we're good. What about on this one though? If I plug in the 17, 17 times 0.6, so that's a little more than half of 17, so roughly I don't know, maybe 9 or 10, somewhere close to there. Still a positive number that we're taking the log of. So all the ones that we've done so far are good. Okay, so I should have mentioned that before we started solving, but there may be cases where the answers you get actually don't satisfy the original equation. Extraneous solutions, possibility here. All right, so we'll check that for on the rest of the problems that we do. And so from here, now I've got the natural log of the square root of x plus 2 is equal to 1. All right? And so right away, I'm ready to just kind of rewrite this thing. So remember, this x square root of x plus 2 is going to be equal to the base. Well, what's the base of natural log? It's e. And it's going to be raised up to this power. Well, e to the first power is just e. And so I have square root of x plus 2 equals to e, and I need to try to solve it. Well, how would you do it? I'm going to go ahead and square both sides. So squaring both sides gets the x from under the square root, and that's going to be equal to e squared. Okay? So from here, we can go ahead and subtract 2. So my x is going to be equal to e squared minus 2. And once again, it's calculator time. Now, if you're given choices in terms of e, this would be the answer, and that's a possibility because, you know, sometimes you've seen problems where the answer's in terms of pi. Okay, so e is the same way. You may see some assignments where the answer is in terms of e. So this could be your answer choice. However, if they have them in decimals, then you're just going to have to go to your calculator and see what the decimal equivalent is. All right, so that's what we'll do here. So I'm going to go ahead, e, we're going to raise it up to the second power. Then we'll go minus 2. And so there's our answer. We'll write it as 5.39. Okay. So once again, we need to make sure that we're not in a situation where we're taking the log of a negative number. If I put 5.39 in there, that's 7.39. Square root of 7.39 is still a positive number. So we're in good shape. That's your answer. All right, what about the next one? Let's see. Okay, so on this one, you've got several natural log terms. And the first thing I'm going to do on this side is use one of the properties we had learned in the previous lesson to combine these together. So I'm going to write this. Natural log x plus 5 equals. Remember the property, if you have terms, natural log terms subtracted, we can write it as a quotient. That's the natural log of x minus 1 over x plus 1. Okay? All right, so we're using that property. So now what can we do here? Okay, so the next thing that we want to do here is recognize that this is natural log base e. Natural log is base e. And so remember what we said? If the bases are the same, then this part has to be the same. So we can really just knock natural log off of both sides. Right? So we can go now x plus 5 equals x minus 1 over x plus 1. Okay? So again, since the bases match, then these parts have to be equal. So from here, I want to get rid of this fraction, right? If I'm solving this, now this is just solving a rational equation. Remember we did that in the last unit, right? So how do we do it? Let's get rid of the fraction first. Times x plus 1 times x plus 1. Okay? So I'm going to have to multiply this out now with a distributive property and get x squared plus 6x plus 5. There, the x plus 1 cancels, so I'm going to go with x minus 1. All right, so getting closer now. So from here, we're going to go ahead and let's see, what do we want to do? We can subtract that x from this side and get x squared plus 5x, and we can add the 1 there and get plus 6 equals 0. Now we're solving a quadratic equation. I can attempt to factor it first, and if it doesn't factor, I'll have to go to the quadratic formula. All right. And so I've got x here, and plus here, and plus here. And let's see, what do we need here? Okay, I need two numbers to multiply to get 6. Okay, but at the same time, they combine together to get 5. When multiplied out and combined together, I'm going to say it's going to be 3 and 2. 3x plus 2x is 5x, and we have factored it. All right? So from here, I can say that x is equal to negative 3. Oh, negative 3? Yeah, negative 3 and negative 2. All right, so those are my solutions. Or are they? Remember what we said. We got to make sure that we don't have answers here that is causing us to take the natural log of a negative number. What about in this term? Negative 3 plus 5, still positive. Negative 2 plus 5, still positive. What about here? Negative 3 minus 1, that's negative. So that negative 3 is out. Negative 2 minus 1 is negative 3. So negative 2 is out. Also here, both of these wouldn't work. So I don't have either one of these two as answers. And so really what that means is I've got an equation here with no solution. Because both of the answers that we got prove to be extraneous because they don't work in the original equation, because it's causing us to take the natural log of a negative number which is undefined for the natural log function. Right? No solution there. And so that's the answer. I mentioned quadratic formula earlier because if it doesn't factor, you'll have to use a quadratic formula. And I believe there may be one on your quiz where that doesn't factor. So that's why I mentioned that to you. All right, so at this point, you have everything that you need to go and take the quiz. And I'll see you in class.